All right, this is a quick video about Faraday's law. Sometimes it's called Faraday's law of electrolysis, Faraday's law of electrodeposition. And there are various formulas you can look up for this, but I think it's just conceptually easier to think about how this works. The idea is that you use Faraday's constant to take the charge value that you record in an experiment. That could be chronoamperometry, if you are keeping the voltage constant. You integrate that area and you get charge, or it could be chronopotentiometry, you're holding the current and you multiply it by the time, you get the charge, or it could be a cyclic voltammogram. And you integrate the CV and you divide by the scan rate, things I've talked about in other videos. All those are different ways that you can get amount of charge from your electrochemical experiment. You get number of coulombs, right? That's coulomb is the unit of charge. Then you go from coulombs to moles of electrons. So let's say I did an experiment, I got 10 coulombs, and all I do is I divide by Faraday's constant, right? 96485 coulombs is 1 mole per 1 mole of electron. Now I got myself into moles of electrons. From there, I can go to moles of electrons to moles of whatever reactant I want using a balanced equation. Usually Faraday's law is talking about metal that's electrodeposited. So let's say it's copper, I don't know, copper being electrodeposited, right? So you have copper 2 plus, maybe it's copper 2 plus salt, probably most commonly used, plus 2 electrons goes to copper solid that is electroplating. So you know that for every 2 moles of electrons, right, I get 1 mole of copper. Okay? And then for moles of copper, you know how many grams of metal you have, and so you can weigh that out, right? And you can go, for every 1 mole of copper, I believe there's 63.55 grams of copper. Okay, so you multiply by the molecular weight. And then from grams of metal, if you want, you could use the density of the metal, assuming the density of what is electrodeposited is the same as the bulk material, a bulk piece of copper that's, all melted down and nice and compact. Sometimes electrodeposits can be less dense, more porous. That's a way to figure this out, okay? You could then figure out the volume of metal, and if you wanted to, if you knew the area of your electrode, the geometric electrode of your metal, you could then divide by that area of your electrode to figure out the thickness of the metal. So there's all sorts of information you can get from Faraday's law. This is just, the tip of the iceberg showing you in this quick video.